Hi guys, welcome to this new video on building your own Edubot. As the name suggests, we are going to build a bot which will help with your education and make your learning process easier. But the crucial thing to notice here is we are going to build this bot with the help of Langchain, which is a very powerful framework. But the key point to note here is it will run on CPU, and the models used here for the components in this application is completely open sourced. That is the main advantage of this application. So without wasting time, let's jump right into the video. This is how the application will be at the end. Okay, so here we have the title, here is a subheader, and once you enter your query here, then if you click the answer button, your answer will be there. And this chatbot was made by using Streamlit chat framework, and like I said, it is a Langchain powered application. All right, so here if you see, the question was first, hey there, and the bot replied, I am ready to help you, followed by the question was, why do we need to evaluate LLMs, and here it has given a detailed explanation. Okay, and if you're wondering what is this about, see, first what happens is you need to have a PDF, and then you can chat with the PDF basically through this bot. And for this, I've generated the PDF from a video which is going to come soon. Okay, I've prepared the materials for the video which is about evaluation of LLMs is all you need. Okay, it is a very exhaustive video, so stay tuned guys. Based on that notes only, I've created a PDF and then it is being loaded here. So yeah, if you're wondering what is this, how I got this output, it is from that PDF. Okay, so don't worry guys, it will work for any PDF. Okay, I'll show you how to do that as well. Now, like I said, this is the application, and you might wonder, wasn't you usually show the output itself, right? Why you are not showing the output and you're showing the image? See, guys, actually, it will work. In my CPU itself, it is working, and for your CPU also, it will work. But the problem is, I'm running OBS Studio, which is my recording software, and it is consuming almost all my memory, so I'm unable to run simultaneously. Okay, that is the issue. So what I did was I inferenced the application and then I just made a screenshot. So you'll also be able to obtain this specific output once you follow this video completely. So please follow this video completely guys. So yeah, now once you know what is the output, now it's time to know how we are going to get this output. So before moving on to that, I would like to let you know that these are the requirements guys. So I will upload this requirements.txt file also. So make sure that you are creating a new environment, and then maybe conda environment or Python environment based on your choice, and then do pip install -r requirements.txt on this requirements.txt file. Then you should be good enough to go with this project. Okay, so yeah, that would be your installing dependencies section. Now we are moving on to the workflow. Okay, see ya guys, this is the workflow which we will do. Don't I know it's funny to see this kind of duck user interface, but it was the easiest way to create some sensible thing stating that it is from user. Okay, so here what it will happen is actually there will be three stages, but I have concised it into through two stages. Okay, first what we need is we'll have a PDF, and then we'll chunk it, and then we'll compute the embeddings for those chunks, and then we'll create a vector store out of it. Okay, which will be FAISS vector store. And guys, don't worry, if you are not understanding about what I'm saying, you need not worry. I'll be explaining each and every bit. I'm just giving you an overview of what is there in this video after this. Okay, so once you have this FAISS vector store, you will be storing it in your local. So followed by that, user interface here would be our Streamlit app. So that is our app.py file. From there, once the user provides a user query, you will be computing the embeddings for that query, and you will try to make a semantic search based on that query on this vector store which we stored. Okay, In this vector store, there will be embeddings from the PDF, and then it will try to rank the closest chunks. Okay, we have computed the embeddings for chunks and stored in the vector store, right? It will try to rank, okay, this is the most relevant chunk for the given question. So that will become the context for our LLM, which we will be using Llama here. And don't worry, I'll show you which model exactly we are using as well. And then finally, once the Llama gets the context from there and the question from user itself, it will try to generate an answer which is provided to the user via the user interface. So this is how the workflow will be there. And now let's go one by one. Okay. So to start off with, we'll start with vectordb.py. Okay. So here if you see, this vectordb.py is the first step for vector store creation. Okay. So I'm gonna have this workflow.jpg file here itself so that we can compare and see which step we are on and where we are going on. Okay. So the first step would be directory loader. So I'm just not gonna explain the imports here. Once we come down here, I'll explain the imports as well. Okay. So first we have a directory loader here, which will, as the name suggests, load the directory. And here what it happens is it will try to load the files which are a extension .pdf. Okay, so here if you see, I have a config file stating that my data directory path is data. Okay, so in data I have a pdf called llmeval.pdf, and this is in the data directory, right? So what happens in this vectordb.py is it will go to data slash, then it will try to see star.pdf. In this case, there is only one PDF, llm.pdf or llmeval.pdf here rather, and it will try to load that PDF by a PyPDF loader. So if you see, PyPDF is a famous package which is used to work with PDF, and this PDF file is loaded by using PyPDF loader. Okay, so that is what is happening here. So once that is done, you will have your PDF loaded in this docs. Once your PDF is ready, up and running, then what you'll do is next you'll split the PDF. Okay, so here is where we are chunking it. So to come and say here, first your PDF is loaded. Next we have this chunking step, right? So this is the chunking step. And now to come here, we are using a text splitter known as recursive character text splitter, which will go one by one, each character by character. Then what it will do is to create chunks. So here if you see, I have specified a chunk size of 500. I hope it is visible. So it will try to get the 500 characters first and it will split it there. Okay, so let's say I have a PDF of maybe 10,000 characters. What it will do is first 500 characters. I'm not indexing it from 0 to 499 for some better, easy conversation. I'm saying it is from 1 to 500. Okay, from 1 to 500, it will be there in the first chunk. Then you might think, Vasant, there is a high possibility that I might miss some context, or else the word might get been cut abruptly, stating like, even for example, let's take this vectordb.py file itself. If I take some 500 characters, possibly it might cut here, huggy. And I might think, man, what is going on here? What is huggy here? So what happens is, in the next chunk, which is a second chunk, obviously there will be 1 to n chunks. Here I have given chunk overlap, right? So this chunk overlap, if you see, what it does is, here I have given a value of 200. The second chunk, the range of characters would be from 300 to 800. Now I hope you will understand. Okay, you have your 1 to 500 in the first chunk, and to not miss your context, you will also have 300 to 800 in your second chunk. So similarly, this 200 bridge will help you to retain the context to a larger extent. So that is what is happening in chunking. All right. So based on this, your splitter is ready. Then you are splitting a document by which your data chunks from data chunk 1 to data chunk n. Here it is n. Sorry, I didn't change, I guess. It is 1 to n. Okay. So chunk data is now ready. So once that is done, we need to compute the embeddings, right? For this, we are using Hugging Face embeddings. Okay. we all know Hugging Face has lot of models. Okay, so if you're wondering, okay, Vasan, which model should I use to create the embeddings? Don't worry, I've got you. I'm gonna show you which model to choose. Okay, I'm not just gonna say I chose this model. Instead, I'm just gonna show you which model I chose and why. Okay, so let's see here. So here, if you see, let me have this first. This is MTEB leaderboard, which is usually for calculating and sorry, rather evaluating your embedding models. Okay, how much embedding, the richness of embedding, and all. Okay, so there are a lot of metrics it has been evaluated on. We are specifically focusing on retrieval, right? So retrieval or overall, GTE large has been in top three, and if you see the size here, it is also not that huge. Okay, it is 0.67, which is pretty much affordable for us. Okay, so we are going to use this library GTE large. So it is from this organization, the NLPER, and if you see, the license is also MIT, which means we can use it. Like I said, this ecosystem which we are building now is completely open source, guys. So yeah, GTE large is the model which we are going to use, and I have specified that in our config here, so which you will be able to see now. So here you can see, right, the NLPER GTE large. That is the embedder we are going to use now, from which we'll generate the embeddings. But here we are also specifying an important parameter stating that the device in which you should execute is CPU. All right. So because if you see, this model has the capability to consume GPU as well, but we are specifying that you should use only CPU. That is what is happening here. Okay. So now our embeddings and embedder is ready, and based on that, we are creating a phase vector store from these documents. Okay, where is that input text? Yeah, these chunks. Based on that, we are based on these embeddings and chunks, we are creating a vector store. What will happen is basically, based on these embeddings, the embedder will try to create embeddings for those input text, which is our data chunks, and then it will store it in a vector store, which is a phase vector store here, or else we'll commonly also say it as vector database. So here you can see, right, we are having the chunk data here, and then it is going to compute HF embeddings. While our HF embeddings instance is ready, and then based on that, we are computing the embeddings for the PDF rather than PDF chunks, and then we are storing it in phase vector store. So that would be the first step for you all to execute, guys. So what you need to do is, when you are executing this specific project, right, first, like I said, create um sorry create your own environment, and then what you need to do is, first you need to execute this python vector db.py. Okay, python vector db.py. Okay, let's run this, and if you see, the data chunk is created and it will work. Okay, so it will work, guys, you need not worry. I have already executed it, so I'm not executing it again, but it will work for you all. All right. So, yep. Next, what is the step? Like I said, your vector store is ready, but now let's go on to this workflow itself. See here, why we executed this vector store first is, this vector store is also used in Edubot. So the next step would be to build this Edubot, which is the backend for our application. Okay, so let's move on from this vector db.py to edubot.py. So here, if you see, we are having a Edubot creator, like the name suggests. It is a class which we are using to create our Edubot. So yeah, first we are having a custom prompt template. So before moving on to this specific one, I would like to show you one another important link. All right, just give me a minute. So here you can see, this is the FAISS vector stores official documentation. FAISS, okay, FAISS is a library. Like I said, it is used to make semantic search, vector related stuffs and all. Okay, so this is from Meta. And if you see again, this is also MIT licensed. Okay, which means it is open source and we can use as per our condition in this video, which is to use only open source components. All right. So here, if you see, we are gonna use retrieval here. We also know that, right? So I'll also show you from where I've got this inspiration, which is obviously from the Langchain documentation itself. Okay, so here let it be there. I'm just gonna go to the code again and then we'll come back here in some time. Okay, so coming on to here, we have a prompt template here. Obviously, this is from config file. Okay, so I have given a custom prompt template, and basically the idea is to say that if the model knows what is the answer based on the context which we are providing, which is being got from the vector store, right? That is the context here, and based on that context it should answer the question. And if it is not able to find an answer based on that question, it should not generate anything. It should say like, I don't know, or something like that. It should generate only helpful answer, no misleading answers. Basically that is the idea of this prompt template, and I hope you get the idea. And yeah, you can also create your own prompt template based on this. Next we'll move on to the other variable with the other variables and all. Okay, so next we have input variables here. If you see, we are using context and question as our variables, right? So context and questions are our input variables. Followed by that, we are having a chain type called stuff, which is we'll see about that. Okay, when we are going on to Langchain's official documentation, we'll be seeing about in detail about prompt template, input, chain types, search keyword arguments. I'll say when we are using it. Embedder, as you know, we are using GT large. Vector database path is FAISS/education. In that location only, we have also saved our vector database. So here, if you see, we are saving it in local. So that is in FAISS/education. Okay. So yeah, that is there. Next, we are also having the model type as Llama because we know it is Llama model. And don't worry, like I said, I'll show you which model we are using and where to get it from. Okay, max new tokens is 512 because we are having uh, limited computation, right? So we are not going beyond 512, and the temperature is to control your generation, like the randomness in the generation. It is controlled by temperature, and we are using 0.9. And yeah, if you want, you can experiment with that as well. Now coming on to the create Edubot. Okay, so here if you see, the first step is to create a custom prompt function. I'm clicking it here, which is going on from there to here, right? There is a function called create custom prompt, and it is having a class called prompt template. And here if you see, it is written directly that it is a prompt template for a language model. Okay, it will have a string template and it will accept a set of parameters. So here our parameters are the prompt template itself and the input variables. So what is the use of this? Just hold it for a single minute or two, maybe 2 minutes. Once we go to this retrieval QA chain, you will understand that also. Okay, so the next step is to load the vector database. So here if you see, we are loading it. First we are getting the embeddings, and based on we are loading it, loading the vector database and the embeddings as well. Okay, so that is there. So here we have the custom prompt ready, we have our vector database ready. So before moving on, let's see what are all ready in the workflow. Our vector store is ready, guys. Next we have this computation part ready, and also we have what do we have, user query, because the user query is going to be made as a custom prompt and it is going to be computed for embeddings, and then only it will go for semantic search. So we have these three components ready: FAISS vector store, user query, and compute embedding. Next we need to do semantic search. Followed by that we need to rank results. Then we need to pass it to Llama, and then we need to generate answers. Trust me, guys, it might sound very exhausting, but it will be over in just 4 lines. See here, there is this retrieval QA chain from Langchain itself. Okay, chain for question answering against an index. Index means like usually what it does is in vector database it will detect the index of the uh, rank high ranked context, which is the most related. Okay, most related or most relevant rather. So here if you see, we are using a chain type. Like I said, it is stuff, and don't worry what it will do, I'll say later. And coming on to this workflow, first what we are doing is we are creating a retriever, right? So what the retriever does is it will try to have a semantic search, and it will try the on the it will try to have a semantic search on the price vector store, and it will try to rank the results. Okay, and based on that we can extract top k results. Okay, maybe top 5, top 10. That is what is happening in retriever. So here if you see, we are using the vector database as our retriever, and the search keyword argument is k is equal to 2. Okay, which means top 2 results. Okay, whichever context in top 2 has the high similarity to the question we asked, then it will be retrieved. That is what is happening here. So which means as per our workflow, now we are done with computation of embeddings to the question. Semantic search is done. Based on that, we have got the context. Now we have the context, we have the question, we have the maybe, yeah, the context is there, question is there. That is enough. Now what we need to do, we have a retriever, we have a vector database, these two are done. Next step is to generation. Okay, so here if you see, for our generator we are using an LLM called Llama, right? So this is not very new for us. This is as same as Code Llama. If you haven't checked the video on Code Llama, I've give it in the I button. You can just check it out. So here if you see the model checkpoint here, we are using Llama 2 7B chat GGML D3Q41. It's a so long name, guys. Instead of saying about that, I'll rather show you the model itself. Okay. So yeah, here is the model. And here if you see, the sizes are varied from 2.87 to 7.16, and I'm using Q4 1.bin, which is 4.21. And if you're having a lower computation system than mine, which my system is i7 12 gen, and this is running smoothly on my system, and if you are finding it difficult, then you can try with Q2K bin also, which is lightweight. Okay, so download this in your local and then start installing your requirements and all, because based on your network connectivity it will take time. So here you can see it is 3 GB, it will take some time, right? So yeah, I encourage you to first do this. Okay, download the model. And coming on to the code, then we'll move on to retrieval QA chain explanation. Okay, so coming on to this code, here we have this LLM being loaded of the parameters we already spoke of, and that LLM is provided to the retrieval QA chain. Okay, along with that, the chain type keyword arguments, in that we are saying that our prompt, which is our input, is the custom prompt. Okay, based on this prompt only, which is we have seen already, right? This prompt with information provided, and yeah, you can read it once this video is completed. You can go through the prompt. In that prompt only, you should execute the retrieval, and then followed by that answer everything, question answering. Yeah, basically this is retrieval question answering. Retrieval followed by question answering. Here if you see, this is what we commonly known it say it as RAG. Okay, retrieval augmented generation. What it is happening is, first we are retrieving most similar context, and based on that we are augmenting our generation, which is like, we are playing with our generation basically. And this is one method which we can use for dynamic updation of the model's knowledge. Okay, so you will hear about this very soon in our videos and all. So like I said, we are initializing this retrieval QA with the LLM, the chain type, the retriever, which is our vector database, and then chain type keyword arguments with the prompt as our custom prompt. So by that the bot will be created, and then the bot is returned. Now to come on with how this retrieval QA chain. Let's see an overall introduction. Why this custom prompt? Why it is written as stuff here for chain type? We'll go through that in a minute. Okay. So here if you see, we have our QA using retriever. So here basically if you see, the chain type is stuff. That is what being used here. But if you are going for a normal implementation, the most simplicity kind of implementation, it will be map reduce. Okay. And what it happens is, it won't give you a lot of flexibility to play around with the parameters. Okay. So to make it very easy, it is usually given as stuff. And if you're wondering, wasn't you asked about prompt template? Don't worry, guys, we are gonna come there now. So the custom prompt template is usually made as an input to the model, so that your model gets an input basically, which is kind of forcing it in a way to generate in a specific way. Basically, I hope I make some sense. See here, what happens is, here we are having a custom prompt template in which it is saying that, like I said, it will just say that don't answer some rubbish questions, try to answer it appropriately. But we were asking for some helpful answers, and it said, like, here they have said that answer in Italian, and finally it also returned the output in Italian. To make the model generate as per our requirement, they are doing some prompt engineering, guys. So that is what is happening in custom prompt template. So we are done with the custom prompt template. We know how it works now and why it is being used, and chain type also is done. And now coming on to the workflow. Okay. So here, if you see, based on this retrieved context, and we have also provided our LLM, what happens is this retrieved context and the question from the user query being prompted as our custom prompt together will go as input to the Llama, and then finally the answer will be generated. Okay, so that is what will happen via this Edubot. Okay, so now our backend is created basically. Now next, what we need to do, we need to create our interface, user interface, right? So we are using Streamlit application, and basically, if you see, we are using Streamlit Chat, and we have used Streamlit Chat previously in our Flantify Chatbot video. So if you haven't checked that Flantify Chatbot video, I recommend you to check it out now. So now going on with this create Edubot function, we'll go function by function. Okay, so here, if you see, create Edubot function is there, where I'm creating an instance of that create Edubot creator, and then we are getting the Edubot. Basically, that is what is happening here. And we have cached the resource because this Edubot is not going to change over the course of inference. Next, we have this infer Edubot, which will take a prompt as input. So basically what happens is, it will provide the prompt to the Edubot and it will give some result. That is what is going to happen. We'll come to the display conversation at a minute. Okay, before that, we'll see what is happening here. So, and you might wonder, once we are seeing the input, you might wonder of a question. So I'm just keeping you curious what question it would be. But yeah, I'll also say what question you might get once you see this. Okay, first, what we are doing is, we are creating a title known as your Edubot, your smart education sidekick, and subheader is a bot created using Langchain to run on CPU. There also I'm making some mistake, to run on CPU, making your learning process easier. Okay, so that is what is a subheader, and we are asking the query for a user, from our user. So here, if you see, next what we are doing is, we are having two session states. Okay, so what is a session? Like, once you start a conversation and till you end that, it will become a session. Okay, and there are two session states, which is user session states and bot session states, and you can name it however you want. Okay, so I have named it as assistant and user. So if the user states that, like, if there is empty, no, what I'm doing is, I'm saying that user is saying hey there, and in assistant session state, I'm giving the first value to be I'm ready to help you. What it will do is, it will have a history of conversations. Okay, so that we can display the history of conversation. Even if you see here, this hey there, I'm ready to help you, why do we need to evaluate LLMs, and these are there, right? To have this history of conversations, you need to maintain a session state basically. Okay, so now coming on to the st dot button. So here also you can see there is this button, right? Once I click this button only, the model will infer. Okay. Here if you see, we are providing query, which is the user input. This is where the question will come. You might think, wasn't you said context and question would be the input, okay, to the model, and here only you are providing the input. So here, see guys, what happens is they have written a beautifully powerful framework. So we can put how many adjectives we want to explain its capabilities. But yeah, it is very powerful. What it does is it will take this query and it will make a prompt based on this. Like, first it will retrieve the context, and then based on that, it will frame it, frame the prompt based on this question, providing this query into the question section. Finally, the input will be provided to LLM. All will happen by itself. You need not do anything. Okay. So that is why we are providing it as query as user input. Okay. So now what? See here. This is from user, right? So we are appending this user input in user state. And once we get the answer from the Edubot, we are adding it into assistant. So if the session state is assistant, because why this condition is there? You need to generate only when the assistant has generated something, right? So like, maybe you can also play with this, like, once the session state is updated, just make a display conversation. That is also possible. So this will help you to display the conversation. Now coming on to the display conversation section, like I said, you won't have a kind of single conversation, right? It will go for multiple levels. You might ask some multiple questions to your bot, because yeah, we are learning, and then we'll have multiple questions when we are learning a book or PDF or any resource, which is the aim of this application, obviously. And here if you see, you'll have a long range. So we are traversing towards all the history of conversation, and we are just printing the message, obviously. Okay. We are creating a message component where if it is user, then I'm mentioning that it is a user, is user equal to true, which makes sure that there is this smart guy image near the message. And if you see, user messages will be on the right, and chatbot messages will be on the left. Okay. So to ensure that is user equal to true is set when it is user's state, and when it is assistant state, it is not set. Okay. So this is how the display conversation is displayed. And finally, yeah, these are all in a main function, and you can call it here. So what you should do, like I said, first execute the vector.db.py file. And before that and all, you need to download, like I said, download the Llama file, then run the vector.db.py file. Once that is done, you need to execute this streamlit run app.py. Like I said, I'm not going to show you how the execution, because system will crash, okay, for me. And if you think that your system is slow or something like that, try with some lightweight model, like I said. Okay. So yeah guys, that's it for this video. I hope you all like this video. If you like this video, just click the like button, and it will help me to know that okay, you like these kind of content, and it is a great motivation for me to create consistent content. And yeah, I hope you all like the video already. I know you would have by now, and thank you for that. And followed by that, I will also like to ask you that share it among with your friends and communities, and also mention your opinions and your suggestions, and if there is any request, post that also in the comment section. I'll read every comment, and I'll try to reply for every comment. Okay. And yeah, that's it for this video guys. I'll see you all in the next video. Until then, cheers.